Hi everyone, today we'll discuss one more problem on sequences and series. A long problem. Long problem means we have to apply two tests to get the answer. Test for the conversion. Short problem means only one test. So we are applying two tests to solve that. First I will go with the D'Alembert test. Then logarithmic test. Let's go. And this is a very important problem. It appeared it appeared three times. It may appear again. Please see here, very smart problem, logical problem, given, write down summation, n term is not there, so first we have to write the n term. You see 1, 2, 3 factorial, so n factorial, x to the power of n, you see n is there here, one more extra is there. So this will be n plus 1 to the power of n. 2 is there, 2 is there, 3 is there, 3 is there, see here. So un is this one, n factorial x to the power of n by this. Now I am doing, this is our un. What is our un? N factorial x to the power of n by n plus 1 whole to the power of n. Now if you go for un plus 1, this will be n plus 1 factorial x to the power of n plus 1. This n plus, wherever n is there, we are writing n plus 1. That's it, not doing anything extra. So now un by un plus. What is our un? N factorial x to the power of n divided by n plus 1 whole to the power of n. Un plus 1, this will go to the numerator, n plus 2 whole to the power of n plus 1 by n plus 1 factorial x to the power of n plus 1. Okay, now we have to simplify. See here, n plus 1 can be written as n plus 1 into n factorial. So this n factorial get cancelled. This is x to the power of n into x. So this x to the power of n cancel. So we are left with this part. So we are left with n plus 2 to the power of n into n plus 2 numerator, denominator n plus 1 whole to the power of n into n plus 1. Okay. So, and one more thing we are forgetting, 1 by x is also is there. So, this will come as n plus 2 by n plus 1 whole to the power of n into n plus 2 into n plus 1 into 1 by x. What I am doing here, taking n common. If I take, you see, n plus 2 by n plus 1 is there. If I take n common from the numerator, 1 plus 2 by n, if I take 1 plus 1 by n. So n getting cancelled. So this is 1 plus 2 by n whole to the power of n by 1 plus 1 by n whole to the power of n. Again, if you take n common, this is 1 plus 2 by n into 1 plus 1 by n. 1 plus 1 by n. Okay. This is our un by un plus 1. Un by un plus 1. Now apply the limit n tends to infinity. Apply the limit n tends to infinity. Limit n tends to infinity, 1 plus 2 by n whole to the power of n is e square. Remember standard property. We are forgetting 1 by x. So this will be 2 is there, so it is e square by e And this is as n tends to infinity, 1 by n tends to 0. So 1 plus 0, 1 plus 0 is 1 into 1 by x. So this will be e by x. Answer is e by x. So answer is e by x, un by. Now e by x. Limit n tends to infinity, un by un plus 1 equal to e by x. By ratio test, e by x greater than 1, convergent. By D'Alembert ratio test or D'Alembert test, e by x less than 1, divergent. E equal to, you see x equal to e or e equal to x, the test fails. Equal to x, test fails. D'Alembert test fails. So now what will happen when x equal to e? Now we'll see what will happen x equal to e. Whenever e is involved, we have to apply the law. Okay? Whenever is involved, we have to apply the law. Now what we have, un by un plus 1 equal to, what can we write? You see here, this part. I am taking this part. So this is n plus 1. So what is this? N plus 2 by n plus 1 whole to the power of n plus 1 into 1 by x equal to e. This we have. Now applying log both the side. Log of un by un plus 1 equal to log of n plus 2 by n plus 1 whole to the power of n plus 1. Okay, into 1 by e. Now multiplying by n both the sides. Multiplying by n both the side. Okay. So now n outside. What we have? Log a to the power of m is m log a. So n plus 1 into log of n plus 2 by n plus 1, n plus 1. This is log. Log of, we apply log for both. This is log of a to the power of m is m log a. This is log e. 1 by e is minus log e. So now n plus 1. What is this? Log of a by b. Log of a by b is log a minus log b. So log n plus 2 minus log n plus 1. N plus 1 minus log e. Okay. Now, please remember log of 1 plus x equal to x minus x square by 2 plus x cube by 3 minus plus will go on. Okay. Now, n as it is, n plus 1 as it is. This is log of a minus b. You see, we will take this thing, log of this thing, n plus 2 by n plus 1 plus 1. This I am combining. I am not opening. I am combining. Minus log e. Let me write down one step. Now, this can be written as n plus 1 This is taking n common. So this will be 1 plus, you see, 1 please, 1 minute. You see n plus 2 by n plus 1 can be written as n plus 1 plus 1 by n plus 1. So this is n plus 1 by n plus 1 plus 1 by n plus 1. This is getting 1 plus 1 by n plus 2. So 1 plus 1 by n plus. Log e is 1. Log e, because to the base e, log e to the base e is 1. So this. Now expanding by log. You see 1 plus x form. So this equal to n outside, n plus 1. Now if we expand the log, first x. What is x? X is 1 by n plus 1. 1 by n plus 1 minus 2 into n plus 1 square plus 1 by 3 into n plus 1 cube minus plus minus plus so on. It goes. It goes and goes on. It is minus 1. This is minus 1. Now if we multiply by n plus 1, so this is n plus 1 getting cancels minus 1. This is 1 by 2 of n plus 1 because 1 n plus 1 is gone plus 1 by 3 of n plus square minus plus so on goes on. This is minus 1. This is minus 1. So this is this minus 1, this plus 1 getting cancelled. Plus 1 getting cancelled. So we are left with n is there. So n is common to all. So this will be, if you take n common, 2 into 1 plus 1 by n plus 3 into 1 by n whole square into n minus plus goes on. This is n into log n, un by un plus 1. Now apply the limit n tends to infinity. Un by un plus 1. So this is, if you apply this infinity as n tends to infinity, this complete part. Let me write it down. See here. As n tends to infinity, 1 by n tends to 0. This is minus 1 by 2. As n tends to infinity, 1 by, this is n. 0, again, this is 0. This is 1. So 1 by 0. So it is gone. So we are left with 1 by 2. We are left with 1 by 2. Minus 1 by 2 less than 1. Less than 1. Therefore by logarithmic test, the given series is divergent. Divergent when x equal to e. It is less than 1. So divergent at x equal to e. That's it. A little bit long problem, but this is for long question only. See here. So first we applied the D'Alembert test. So the test says when x equal to e, test fail. Whenever in the problem, whenever come e, you have to go for logarithmic test. Whenever it is come another test, then we'll go for Rabi test, other test. But here e is involved in the problem, so we have to go logarithmic step. So applying logarithmic, then logarithmic expansion of log. I have written the basic formulas what we have used here. And here we did not use this, please. Here we don't use this one. We did not use here. So we adjusted this n plus 2 by n plus 1, this thing 1 by n plus. Then now after that we apply log of, after that we applied this one. So then 1 by 2 less than 1 minus 1 by 2 less than 1. So therefore the given series is divergent by logarithmic test when x equal to e. Thanks for watching. Please do subscribe my channel and share with your friends.